Hey everybody, we're moving on here to section 4, improving the design when it comes to this process of data normalization and looking at how we can be storing this data properly. So normalization is just one part of this whole process. Other things that are going to lead to better data storage is this next portion here. So normalization, yes, but then there's further things we can look at that's not really normalizing, but it's all part of this database design idea. First, we want to look at our primary keys. So again, it's great to have this unique field in your table. So we looked at that certificate table. We said, okay, here's the certificate. And if your primary key in that table is the certificate name, like PMP or Network Plus or A Plus Cert or whatever, Microsoft Certified Systems Engineer, and they've got a bunch of other certs you could get for the primary key. Great. And then maybe you might have like the full written out name, whatever it might be here for this other field, or I don't know, other data you might have here. Is this actually a good primary key? That's one thing to think about, because yeah, it's nice here, but if we have to be picking this from a list, or if we're letting people type things in, what happens if, again, we run into those issues if someone does Net Plus, right, as a different possible certification? We are still kind of limited in what's happening here, and possibly could lead to redundancy. So some of this can't be fixed at the database level. Some of this needs to be done at an application level, where the person, whoever's entering our data, is going to be looking through it, trying to figure out, okay, this is the right one in the list, or no, I really do need to add a new one here. But some of this we can avoid, right, by putting, in this case, we can't deal with a Net Plus versus a Network Plus at the database level, but one of the things we don't necessarily want to do is have to store long strings in another table. So when we look at that joining table and we say, I don't know, certified or something, and we'll say, okay, one certificate can be, many people can have that certification, right, for a given certificate. If we have to put that whole string text in this table, the data is a little bit larger. So what we'll commonly like to do is we'll add that identity field here. So this is just an ID column, 1, 2, 3, that's system generated. The surrogate key is a lot of times we might call it that. And the surrogate key is great because then I can say, hey, it's certificate number 2 for employee number 27 or something like that. And we had our employee ID and then certificate ID for our certification table. And then, we can put the date they were certified, I don't know, 9/29 or something. Sure, we could store all that here. Now, that's great for storage, and it's more efficient to store a single integer rather than, hey, the entire Network Plus. Again, a little bit of storage is not too big of a deal, but if the larger these things get, the more and more data we're storing, the bigger of a deal it is. But if we go with this surrogate key here, so just our system-generated ID, it's easy then at the system level, or at the database level, to have two different Network Plus certificate entries. So one of the things you can do at the database level to prevent that is to add a unique constraint. It's, hey, these entries must be unique. They could be a key, essentially, right? They're a candidate key. It could be a primary key, but we want to use this surrogate key because it's going to be easier for all of our linking down the road, a little bit more efficient there. But then we need to make sure at the database level that we have unique entries only. So again, it still doesn't fix the Net Plus versus Network Plus, but it prevents the same row from being added more than one time here. So looking at primary keys is a big portion of that. I'm a big fan of these ID fields for almost everything. And I think that just makes life a lot easier here. Another step is looking at all of our names. So all of our attribute names need to be nice and clear as we're looking at designing here. And again, I don't like the book's example, how they take the table name in front of everything. That's kind of obnoxious, right? If you're in the employee table, it's name field. So employee.name is the employee name rather than emp name for employee name. Again, sure, either one's fine. Just pick one and stick with it. But when it comes to other naming conventions, you want to be nice and descriptive, right? If you're talking about hours, right, that someone has, is it hours per day? Is it hours per week? Is it hours per month? Hours per year? So you need to be very descriptive with what the field is so that we're going to use it appropriately. So looking at names specifically, and looking at the atomicity. Atomicity. I can't spell, friends. I'm sorry. And again, this is all about, can we break down an element or an attribute into something smaller? So something like name really is first name, middle name, and last name. So we could break that down further when we do things with name. Most of the time, this is what we want to do. You can get a little funny with middle name because some people don't have middle names, but usually you want to store first name separate than last name. You don't always want to get an alphabetized list of employees, but if you did want that alphabetized list of employees and all you had was name, it's really hard to sort on the last name that's in there. So usually storing them separate, right? Each particular item here is separate. Now, name's not really, it's not a multi-valued field because like first name is distinct from last name, but we didn't break it down far enough. So name is very common for this here. Anything else where we're storing something that we could break down further. And then we want to look for additional attributes. Okay, what other attributes can we have? So new attributes. What new attributes can we add to this so that we can store the right amount of information? We need to make sure we're taking care of all of those business requirements as we're going through. We're going to look again, hey, was there other things we needed to add? Especially as we did this normalization process, we might have gotten a couple more tables. So maybe there's another chance to store something in there. Like when we looked at certification, hey, what's the date you were certified, or is there an expiration date? Those fields didn't really exist in the previous, hey, here's the list of certificates this employee has. We want to look at relationships as well. Relationships. And to make sure that we are properly storing the right relationship between these different entities. Many-to-many relationships are really common. So we need to make sure we're doing the right joining. Sometimes a table can have more than one relationship to different other entities, right? So like the book's example of project, employees are assigned to projects, but then you also have a single employee who is the project manager for that project. So like the employee table is going to relate in two different ways to the project table. And that's okay. We have different levels of requirements here, and that's fine. And then in terms of granularity, right, are we storing the right level of detail with that? So when we had, I think we looked at, we're being invoiced. So if we have an invoice table, right, so from our suppliers, when we go order things, they're going to send us an invoice. Are we storing the right amount of details in here? Right? If all we have is an invoice number and like the total here, it's not really a whole lot of detail. So maybe we want to have individual line items. We might store that invoice line item. Right? And one invoice then could have one or many line items. Right? You're not going to have an invoice without a line item. So at least one line item. So I think that's a mandatory here. So that way we can store additional information like, hey, what's the particular part number? What's the quantity? Right? What's the price? That sort of thing. So getting the right granularity of detail so we can answer some of these questions later, making sure we can store everything is important. Making sure that we have this historic accuracy is important. So when you go register for a class, right, you have to pay some cost per credit. So if we're going to put an entry or send you a bill, we don't want to have to be calculating that on the fly based on the current cost per credit, because if that cost changes every year, like it likes to always go up every year, and if we haven't stored that information, when we calculate, hey, what was the cost for that class? Right? And we said, oh, it's currently $100 a credit hour. If next year it's $102 a credit hour, times the number of credits, the bill's going to be wrong. So we need to make sure that for historical accuracy, this is one of those cases of controlled redundancy, right? So when you register, so a registration probably relates, like this registration entity probably relates to a charge entity, right? And the charge then will have, hey, what class did you register for? So one registration will generate one charge, right? A nice one-to-one here. So the charge can reference the registration, but then we're going to include, right? This might have the credits, and then the cost per credit. And then if you go drop the class, or if you withdraw, if you unenroll before the class has started, right, we can remove that registration and remove the charge. That sort of thing. If you drop, usually you've already paid for it, unless you're within the drop add period. And again, there's a little bit of funniness that has to happen there with the dropping status, but in our registration table, we'll probably have something to relate to that. So we can say, okay, here's the charge, here's the cost per credit at the time when you registered. And then next year, forbid you have to take the class again, you register, you get charged the new rate here. So you get a new charge at the new rate here. So that's the historical accuracy of all of those pieces of data. Again, another controlled redundancy. We also want to look at derived attributes. Now this is the registration example is really good here. So in our registration table, right, we have the section, and we have the student. These are both IDs, right? Section ID, student ID, and then I think we probably were going to store your grade. So it would be easy enough for us to calculate, say, okay, section, go find the course you relate to, course giving the number of credits. So we're going to look at the course credits, right? And then look at the grade, calculate your grade points that you earned based on the grade, based on the number of credits, total all of those up, divide them all by the number of credits you've taken to calculate a GPA. We can derive the GPA anytime we want. Yes, we definitely can. The problem with that is you have to do all of that arithmetic every single time you want to find GPA. So there's a little bit of a trade-off. So the good of that is that we're making sure we always have the latest and greatest version of that data at every point in time that we use it, because we're always calculating it fresh. The downside is it takes time to do that calculation. So if I wanted to run, say, hey, where's the dean's list? All the students have a 3.0 or better. Well, I'm going to have to go through and I'm going to have to calculate for every single student in the database what their GPA is, and then I can look at it. Versus, hey, maybe at the end of every semester when grades are posted, we go and calculate the GPA and we store GPA in the student table. Right? In that student table, maybe there's an attribute in here for GPA. Right? And then we can go and we can store that calculated GPA, and then every time grades post, we can go and update it with that sort of process. So it's a little bit of a trade-off, and you want to consider what is going to be best. Do you want the latest and greatest info, or do you want the performance? And then you just have to deal with making sure you keep it up to date. And it kind of depends. It's not too big of a deal here, one way or the other. So really, the more often you use it, the more computational power it needs. So if you are looking it up more often than you are changing it, it's probably worth storing it instead of deriving it every time. If you're changing it a lot and not really using it as often, well, then you're probably better off deriving it when you want it, right? So just some of those trade-offs. And then the next section looks at those higher level normal forms. Again, we don't really care too much about Boyce-Codd normal form or fourth normal form. Not too big of a deal. We're not really going to run into those in any sort of implementation. They go through all sorts of time working through those ones. All right, so why don't we take a break here, and we'll come back to the last little bit when we talk about normalization, denormalization, and then our final checklist.